Great. Good morning on the second day. I have to say it's a pleasure to be here as a speaker in Warsaw after 6 years of break. Let me put on the timer. I like to keep in touch with how I'm doing. My name is Łukasz, and today I will be telling you a bit different thing than yesterday. It's about transformations. Organizational transformations, very complex ones. It includes a lot of buzzwords in the title, and the key answer I will try to give you is it worth? And with such complex transformations, let's try to think how to measure it, how to define that we did a successful one. If you haven't met me yet, yesterday, to fed my ego, I'm engineering manager. I like to do a lot of hands-on coding, building systems. I consider myself a true remote worker. I like to work not in the office, but by the lake, on my bicycle, on Raspberry Pi, on Samsung Galaxy connected to the screen and Bluetooth keyboard. And I'm the guy that works with logs. Let's start with a bit of theory. Those are terms that are very much familiar for you, but as they have like a dozen of different versions, let me quickly share how I understand them. DevOps is a term that is 15 years old now. It's 15 years, so it's a lot. And initially described by Patrick Debois in Belgium, it emphasizes on cooperation, on shared responsibility of operations and developers. On the other side, NoOps is a relatively younger term. It allows us to leverage from the platform as a service, self-service systems that exist now in the 21st century, which allows us to build seemingly complex infrastructure with a few clicks without the need to hire a dedicated expert, which is way better than in the bare metal times. And SRE, this I need to read because it's too long and sophisticated. It encompasses principles and practices that integrate software engineering with IT infrastructure and operations to enhance system scalability and reliability, which means it's like DevOps. It's all about cooperation, but here it's to leverage from each other. And if we want to have a system that is reliable, what does it mean? To me, reliable means it serves its purpose in a timely manner and it's available. And what can be measured? If we want to have a reliable service, we need to have it available, performant, providing the expected value, and the error rate can be an explicit error rate, meaning stack traces, exceptions, 500 error pages, or implicit, which is, okay, there are no errors, but if you click in e-commerce on the shopping cart icon, you expect to get a shopping cart, not a product list. And also there is a capacity, sometimes called saturation as well, and throughput called the traffic. Those four, latency, error rate, capacity, and throughput, are called, in Google SRE book, 4 golden signals of monitoring. And they provide information about well-being of a service that is up and running. But what happens if the service is not running, if we have a crash? Then we have another set of metrics. They are way more difficult to explain, like MTTR. MTTR means mean time to recover. So when our service is down, how much time does it take to bring it back to the fully operational mode? And very often, people make mistakes by starting measuring MTTR from the moment that, I have a pointer, from the moment that it has been discovered, not from the moment that actually happened, for example, overnight. And we want to minimize that time. We want to bring it back to the stable state as fast as possible. On the other hand, MTBF, another nice acronym, mean time between failures, gives us the ability to measure how much time there is between one failure and another. And this is, in my opinion, one of the oldest metrics from the pre-computer era, because in the factories in the early 40s, you had analog dashboards showing you a number of days since the last failure. But what happens if we have a total outage of the system and we cannot simply fix it? We are talking then about disaster recovery. It was a really great talk yesterday about disaster recovery and its importance. Restore time objective is a time that you need to restore the system, fully or part of it. In other words, as I like to explain to higher management the technical business aspects of technical problems, this is the answer to the question, how much time can we afford to have our systems not operational? As little as possible. I gave the similar talk some time ago in Poznan, and one person approached me asking, okay, but we are living in the 21st century. We have cloud-native solutions. They are offering backup as a package out of the box. What do we bother to do additional RTOs, disaster recovery? Because some cloud providers, from time to time, like to beat the record of uploading data to the cloud. I'm not sure if you remember that from 2021. And while restore time objective shows us how much time we can afford not to have our service, another point is restore point objective tells us how much time can we afford to lose our data. So if we have daily backups, then it means, in a business language, that we are fine, we can afford to lose 24 hours of our data. There are also metrics related to build time, testing time, and security. And guess what? Business is not interested in how much security vulnerabilities you discover in your systems. It's nice that you're proud that you discovered yet another dozen of security bugs on your production environment, but the real question is, how fast can you patch them? We can also not measure and not optimize anything. I will not be talking about that today. It's more of a risk management factor. Maybe a good point for an open space discussion. And with that knowledge, I joined a company that was looking for an engineering manager with operational background. I was told that this is a NoOps organization, but they need somebody with cloud operation experience to help them cope with the uprising scale. I joined, and I have to say that it was a very pleasant surprise, because this was a true NoOps organization. There were 4 developer teams. They were developing services written in Ruby, Rails, using background processing framework called Sidekick. And apart from them, there was only one security architect who was covering most of the compliance-related stuff. And there was absolutely no cloud admin. How they did it? They set up everything on Heroku. Heroku that I know from the experimenting hobby projects, home labs, and so on. It appears that they used almost every feature that Heroku uses, becoming one of the 3 biggest customers of Heroku in the Central Eastern Europe. It was very easy for them because they had code written in Ruby. They applied Heroku CLI, automatically built applications, pipelines, delivery, all the commits, and so on. They were automatically deployed. Great, all done for them. If they needed a database, it was 1 click away. They clicked, they got PostgreSQL database. You want a read-only slave copy? Sure, another click of the button. If they have struggles with some infrastructure or operations-related topics, they met with each other in a sort of guild meetings called Operations Committee, where a representative of each team was coming to this. They were meeting on a weekly basis, and they were discussing problems that they have, aligning on, I don't know, mass database upgrades in terms of versions and so on. And on top of that, those people have the awareness of increasing scale and the need for a change. Because I learned that the requirement for the operational background for a manager was coming actually from the developers. So it looked great. It looked like utopia. I loved it. But then, the first weekend happened. And the first weekend, I got a call from Chief Product Officer asking me to join them on a Teams channel, because it appears we have a problem in production. Some people are trying to fix it. They are not doing well. It has been an hour already. Can I help? So I joined. And I saw that we had like a P0 outage. Nothing was working. The main database cluster was simply crash looping. It was caused by the extensive load on one of the API endpoints from our partners, so we were like unintentionally DDoSed. And every time they tried to recover the database, it did not warm up the cache, and it was firing again. We managed to stabilize it. While doing that, I learned that people I was working with were just random people that were unlucky enough to see the message calling for help. There was no on-call, no rotation, nothing. We managed to recover that, and bless you. And that made me think, okay, it's not as great as it seems. So I started digging into the problem later on. And the week after, I learned that the problems we're fighting on Saturday were actually happening more often, but usually during the business hours, during the work days, because of the nature of customers, and that they usually don't allow this really to happen. Why? Because this company was they were doing processing of big volumes of data. This data was coming to the API. They were processing that, updating some factors, recalculating database values. If there was an increased load, then Sidekick, with the help of Heroku autoscalers, was spinning off more and more background workers. Those background workers created bigger load on the database. The database autoscaling was not that simple. I mean, it was simple. You could just click, hey, I need to buy a bigger tier for twice as much money. But it took like 2 to 3 hours and had downtime included because it needed to spin off the database, copy the data, and do a switch. So they did not want to do that. So how they did cope with that? One of the engineers was sitting behind a metaphorical joystick. And when the database was becoming overloaded, which impacted the web UI, the users, he was decreasing the concurrency factor, decreasing the load on the database to have those jobs being processed slower. But on the other hand, those jobs were stored, the job queue was stored in Redis. And in that configuration, at times in Heroku, Redis as an add-on was available only in in-memory version. So when Redis has an overflow of data, runs out of disk space, it crashed and was automatically restarted, losing roughly around 5 gigabytes of job definitions. They wanted to avoid that. So when Redis was becoming full, they were increasing the concurrency factor, putting more load on database to consume the queue in Redis. And this dance was taking sometimes up to 2 to 3 hours. On top of that, the Redis itself was also crashing randomly. And later we figured out that the application, seeing that there's a Redis and having some frameworks, automatically used that as a caching mechanism for some internal stuff. And more information was cached, less available space we had for the job queue. Of course, everything was monitored. Everything was great. They had an insight because they had add-ons. They clicked New Relic add-on to each application. There were 15 of them. Each was owned by one particular team. And it provided out-of-the-box great insights into connections, traces, and so on. But it was an add-on to a particular application. And most of the problems happened for cross-application workflows. So they did not have this visibility. So after figuring that out, I decided that I'm not enough. We need to bring some experts on board. But the problem was that I was hired to deal with those kind of problems. And then I came back to the management saying, okay, we need to hire more people. And this was a struggle because as much as they were accepting the fact that we can throw money at the problem. We have increased load, okay, we pay extra $10,000 this month to upscale the database, then we downscale it. It's a one-time payment, we'll survive. Talking about a team of experts and all the costs related to them is a totally different level. After some negotiations, I got the approval for hiring the first site reliability engineer, and then if it succeeds, 2 others. So I started with 1 person. The assumption was that this person would work with mentioned ops committee because hey, engineers were still those engaged, motivated people. They wanted to work with the infrastructure. So we decided to try to leverage from that. So this person joined. He helped to stabilize the infrastructure. We started to introduce unified monitoring. We used Datadog for that. But for a purely license-related reason. So back then, New Relic was messing with the licensing of their offerings, and they were charging not only for hosts and volumes of data, but also for number of user accounts. On the other hand, Datadog was charging for hosts and volume of data, and we could have unlimited number of users. Read-only, read-write, whatever you want. And this was really fitting our situation because that company was a 200-people company having roughly around 15 services, which more or less gave us 20 hosts to monitor. So we used that. We did like a cross-application tracing, monitoring, all the observability, identified some bottlenecks. We stabilized the infrastructure. Some of the databases needed to be moved to another cloud provider because it turned out that with the volume of data we are dealing with, we were actually brushing the technical capabilities of Heroku. So even if we paid them more, they could not do that for us. So we went for a hybrid cloud mode. It was a quasi-hybrid because we went into the AWS, did some configuration of databases in there, and Heroku basically lives on top of AWS, so the connection between them, the latency was minimal. So this was the first plan, to configure, to tune up everything, and then later on, site reliability engineering was meant to be the reliability stakeholders, the enabling team we heard about yesterday. And they were to help, not to really own something, but to keep the ownership within the developer teams. Metrics that we used were the standard, the golden 4 signals, plus the uptime. So uptime performance, the other two are missing, sorry. But apart from those 4 golden signals, we were also using sort of creative metrics. Cost monitoring, measuring time of business workflows, and developer self-reliance. Starting with cost monitoring. This was kind of a measure that was enforced on me personally during those negotiations, because when I got approval for a budget for additional people, there was kind of an indirect expectation that hiring the experts would allow us to save money on other area. So we needed to prove that we're actually having some cost savings in that area. Everybody is doing cost monitoring because we want to have control over how much we spend, but usually it happens like doing a monthly business usage analysis, breaking down into different types of technology tools or pieces of technology, meaning databases, storage, CPU, VMs. We decided to get a bit more granular. Give me a second. We decided to go a bit more granular because we wanted to leverage from the offerings that Heroku and AWS give us. So we used Heroku API, the official one, and if you don't know, there is also an unofficial one that is used in Web UI. You can use the same tokens, but the endpoint is different, and it's having way more functions. However, you need to reverse engineer it, looking at how the front end works. And we used AWS CLI to generate information. So what we achieved, we wrote a script that was continuously monitoring and storing the metrics of CPU usage, which was dyno units from Heroku, recalculated into actual dollars, add-on costs, and AWS costs as a separate unit. And as a result, we had a price tag attached to every of those 15 applications. The later plan was to use that and approach teams for some cost optimization, to look into cost efficiency, if there was a sudden spike in some application of usage, of course, to treat it as an incident, as a cost regression. But surprisingly, we did not really need to do that, because people having that tool available for them at any moment, they started to optimize it themselves. Because if we get a monthly invoice from the cloud operator for, I don't know, $400,000, and I am a front-end developer in some peripheral team doing a fresh new project, I can only look and see and think, okay, it's a lot, but I don't know what can I do to make it less. On the other hand, if I have the application I am owning, and I see that it costs me $3,500, and I see that, okay, but this cost is also affected by Redis instance, which is very costly. And if I remodel the data I'm storing there, I can actually downsize it and save up, I don't know, $1,000 per month. So this is what people were doing. And they were really hyped about that, and we did not really need to remind them about it. And also, as a hint, what did we use for storing those metrics? Because we needed to store and monitor them somewhere. Datadog, because we already paid for it. Second was measuring time of the longest business workflow. This company was processing data. It was mostly an analytical company, and the data was coming to the API endpoints. And we picked the longest and the most important from the customer perspective business workflow, which was called a near real-time monitoring. It was basically listening and getting information into the API from the partners about events that happen all over the world, from different categories, natural disasters and financial crashes in the markets and so on. And it was roughly around 250,000 different events per day. Then we had a machine learning model that was filtering out the irrelevant data. And smaller volume was delivered to the actual manual teams. There were over 100 people working 24/7, 3 shifts, actually filtering this data, reading through them, and deciding which is relevant enough to be sent as an update to our system. And then we had a set of sophisticated algorithms that were identifying the geolocational range of the impact. Like, for example, let's try this not to happen, but if we have an earthquake in Warsaw, it was searching for points that we are having monitored in this geographical region. From those points, they were updated with a new scoring, with new status. Then we were looking for customer accounts that are actually subscribed to those points and this category of disaster. And then from those companies, we're looking for people that are subscribed to actual alerts. Each of those phases were owned by a different team. So, and beforehand, this was measured ad hoc upon the customer complaint or customer inquiry. They were just picking a random event and checking when it happened and when the notification has been delivered. We decided to measure it constantly as a whole, and also each one of the phases independently. And what did it give us? First, it gave us the confidence that we are meeting our service level agreement with regards to the length, to this near real time time span. And on the other hand, each of those teams, when they are doing some improvement, some change, they could actually see how it affects the overall chain of actions. So if a team introduced an optimization in the algorithms, they could see that their part shrinked a bit and contributed to the overall well-being of this land. And what did we use to store those metrics? Datadog, because we already paid for it. And here, a side benefit, which I did not really think about, and I was lucky to actually get that, was we were having this subscription that allowed us to invite pretty much everyone to this observability tool. So we invited the business directors as well. And when we started to monitor, to store such metrics, it was no longer the infrastructure server monitoring tool. It has become a business observability tool, business metrics monitoring tool. So whenever there were discussions about cost cutting, cost optimization, this was no longer a tool that we can be told to, hey, you need to find some cheaper way to monitor your servers. No, it was a business value, and people were thinking twice before telling us to do the re-engineering. And the third metric was developer self-reliance. We did a lot of optimization, a lot of tuning, but bringing the experts on board means they work like the experts. So we started with Heroku, with NoOps. We did a multi-cloud setup with fine-tuned databases in AWS, which have tons of parameters to change. We had a spanning over everything observability layer. We had a few other things that we introduced. And the problem was that we wanted still the developers to be owning those services from the code, from the planning to the very infrastructure layer. But this was not really possible because with every problem, we had this SRE team needing to help them. And at this moment, when we started to see the issue, the team number, as you can see, grew up from 3, 4 to 7, and later on we had 12. So there was a problem, but also there was a chance to do something new, something experimental, because I had a budget for 3 people in SRE. Engineers wanted to be involved in infrastructure because they were interested in that. They were still hyped about it. They were engaged. So we wanted them to do that. They wanted to do that. We needed to figure out the way how to enable them. So after some brainstorm, we came up with this kind of a matrix. So let me break it down for you. Firstly, we have identified what core pieces of technology we would like them to be owning in particular. Because the overarching goal was to have developers be able to do 80% of maintenance tasks on their own, leaving the remaining 20% of very complex problems to require SRE support, which gives SRE some capacity. Developers have the empowerment, they have the ability to change, and they don't need to wait, 3 weeks to have a user added to the database, for example, because we have so big queue of requests. So after defining those technologies, we have described what is the scope of each of them that we are taking into consideration, because it can be very vast. We don't expect people to be suddenly certified in every one of them. So, for example, for Heroku, it was about scaling, restarting, messing with environment variables. For Datadog, it was about monitoring, setting monitoring metrics, dashboards. Why not? For databases, it was about user accounts, scaling or upgrading. And having those two, we needed to describe support levels. Support levels being how much involvement do we need to plan from a SRE perspective in those tasks. And it started with the highest number, where tasks can be handled only by SRE. Moving on lower and lower, having more impact and more share in the work from developers. So support level 3, SRE provides training, documentation, and those people simply do it with active support. More self-confident teams, self-reliant, were just following instructions or using tooling that SRE has prepared. The lowest level was, the almost lowest level was that the developers can do the tasks themselves with occasional supervision from SRE, and 0, not applicable, not used. And having those, we met with each of the teams to work out the initial score. Those are not integers because we took average from all the users, all the team members, not users, sorry. And as a manager of both SRE and those developer teams, I needed to do an official email that whatever we put in this form will not affect negatively your personal yearly assessment, because that was the biggest fear. And having that, we came up with this kind of a matrix. And now, as I'm a manager, I work also with Excel. Hey, I can sum up PostgreSQL values, and that gives me the support level for technology. I can sum up the rows, and I can get, this one is missing. I can get the support level of a team. So you can see teams had different support levels. But that did not mean really that one team is better than the other. We did not do that because they were owning different parts of infrastructure with different technologies and using them in their own way. You might see, okay, the team number 3, their support level is 4, which means they're really self-reliant, right? No, it was the mobile applications team. They were writing an Android application and used barely any of those. But it was good from the planning perspective of SRE, because when we had our OKRs and plans, and we saw what the teams are planning to do, based on that measure, we could also plan our capacity to support them. And all of that could be also summed up in Excel in this yellow highlighted value, which was like a sum of rows or sum of sums, basically all the numbers here. And this is called fitness function. And if I remember the definition correctly, a fitness function is a single number representation of a very complex problem. So we have it, like developer self-reliance, a lot of factors, a lot of variables, one number. And we could use that number to optimize it and measure it, also in Datadog. And this support level was a matter of discussion whenever we were doing our quarterly planning. As a manager, my expectation, my role was to give some expectation to the team and also give them like frames within which they operate on their own, they feel empowered. So for example, I did not impact really how they will do decreasing the support level, because ultimately we wanted to go as low as possible, preferably to the NoOps level. Back then we had this ambitious plan. So for example, I told them, okay, my expectation for the next quarter is to lower the support level by 5 points. However you like to do it. And they did it in different ways. They could focus on one team and just decrease the number of each of the technologies. They could just, along with working with the project, they were decreasing the support level for particular individuals, particular teams. Or like we did with PostgreSQL, this was, they could tackle the entire piece of technology. And here, as we had those databases running in AWS, initially as a quick fix configured quasi-manually, we decided to introduce Terraform and do infrastructure as a code for all AWS resources. And in this Terraform manifest, they have created modules. Modules that allowed developers to have, like in Heroku, those 4, 5, 8, I don't remember right now, different variables that they can mess with in a safe way. And all they did was to submit a pull request, which was reviewed by site reliability engineering members. And upon the merge to the master branch, we had a tool called Atlantis that did the automatic deployment of this infrastructure. This is how we continuously improved. Looking at this beautiful graph I drew myself, the adoption chart for this NoOps, DevOps, full ops thingy is when I started, we had like almost no ops. Then we did a lot of optimizations and reached almost like the full ops model, where everything needed to be accompanied by site reliability engineering team. And then we started to decrease that, and when I was leaving the company, we were on a downward slope, but we did not reach the final goal yet. Of course, if we magnify this graph, it will be rather like a saw-shaped. It will not be so smooth, because when we wanted to introduce Terraform to help with support for PostgreSQL, people had a new tool to be learned. And then when this tool was learned, they felt confident with that. This allowed us to move lower. And conclusions. Was it worth it? Yes. Because initially, NoOps, in my opinion, from my experience, is a good way to optimize costs when complexity and scale is not growing rapidly. If you have some idea, you're a startup, and you want to just build something fast, it's good for you. When you get some more users, when your scale is increasing, it's also not so bad. But just keep in mind that you can throw money at the problem, because those platforms work in a way that, okay, this database is not enough for you, just upgrade to it twice as performant and triple as costly, and so on and so on. So you keep doing that. And the tricky part, especially for the engineering managers in those companies, is to keep track of the growing costs, because there is a point when they are exceeding the budget to hire people that will actually help you manage those costs and make them flat. And what I liked about this journey is that we kept the NoOps as a North Star. as a very distant goal, very long-term goal that we'll probably not achieve, but it's okay. It's something that we urge for, but we understand, we do reality checks that this will never happen. And the last conclusion I have, I like to repeat it everywhere. As an engineer, I was always making myself replaceable, and I'm also always telling engineers I'm working with to do the same. Initially, it triggers an inner fear in people because they like to be irreplaceable. They like to be safe on their jobs. But on the other hand, if you are the only expert of a certain area, a certain domain, and there's a new attractive greenfield project, this is your ball and chain. And when you make your work when you make yourself replaceable, it opens doors to very interesting new activities, which we had for both SREs and developers. Thank you.
So